In this video, we are going to solve the Leetcode problem of the day, and the problem is count the number of good subarrays. In this problem, we are given an input which is an integer array of size n, you can say, and we are given another input which is an integer called as k. So basically, we have two inputs, an integer array and a number k. So right now you can see two examples, example 1 and example 2. In the example 1, the output is 1. In the example 2, the output is 4. Now what is this output? This is the number of good subarrays you can have in your given array. Now how can you find the number of good subarrays? It depends upon the task. This task is going to tell us that what is a good subarray. First of all, we just need to find the number of subarrays. Okay. Now a subarray should be a good subarray if that particular array or a subarray has at least k pairs. K is given in the inputs. So when I am talking about this particular example 1, so what I am trying to find out is how many subarray does I have which has at least 10 pairs. And when I am talking about example number 2, I am asking that how many subarray do I have which has at least 2 pairs. So in example number 1, I can just have one subarray which will have the number of pairs as 10, and in example 2, I have 4 subarrays which is going to have number of pairs at least 2. Remember, it is at least 2 and not exactly 2. That is, if you have 2 pairs, 3 pairs, 4 pairs, all those subarrays are valid and you can count it. So what are the subarrays in case of example number 2? This is from 3 to 2. That is 3, 1, 4, 3, 2, 2. That's one subarray which is going to have at least 2 pairs. What are those pairs? These are the pairs 3, 3 and 2, 2. Now it's very important to understand the definition of a pair as well. What can you call as a pair? A pair is a combination of two numbers. You can say a comma a. Both the numbers has to be same and both the numbers should not be at the same index. That is, you cannot use the same number twice and create a pair. For example, in this particular array, you can take this subarray from 3 to 2, right? This is your subarray and this is what it is. And here you can create two pairs. The pairs are 3 and 3 and 2 and 2. Now you cannot create a pair saying that I will say one pair is 1 comma 1. I can take this one and I can take this one. You cannot take the same number and create a pair out of it. That's one constraint in the question itself. But we can take the numbers which are at different indexes like this. Okay. So this is something which can form a pair, and 2 and 2 can actually form another pair. So from this subarray, I can get two pairs, right? And the question says that any array is a good array or any subarray is a good array when it has at least 2 pairs or k pairs. The value of k is 2 right now, okay, for this particular input. So that's why I am saying 2 pairs. And you can understand it by saying that you need to form k pairs. Now you have another subarray, which is the complete array itself. That is, if you select all the elements, you will form at least 2 pairs or at least k pairs. You can see this is my complete array. I can say 3 comma 3 is a pair, right? 2 comma 2 is a pair, right? So I have got 2 pairs, but I also have one more pair, 4 comma 4. So I got 3 pairs if I am selecting a subarray, which is my complete array. See, a complete array can also be called as a subarray, okay? So this is also valid because I need at least 2 pairs. I don't need exactly 2 pairs. I need at least 2 pairs. So if I'm getting 3 pairs, that is also valid. There is another subarray which I can form, this one. Okay, remove this 3. These elements can also be a subarray, and this subarray is also having at least 2 pairs. You have 4 comma 4 and you have 2 comma 2. So 1 and 2, 2 pairs, right? So this is also a valid subarray. And you have another subarray. You remove this 1 and 3 as well, right? So out of your elements, don't include 1 and 3. You just include these elements, and this is also a subarray which is having 2 pairs, 4 comma 4, and you have 2 comma 2, right? 1 and 2, 2 pairs. Apart from this, you cannot form any subarray which is going to have at least 2 pairs. Okay, for example, if I'm trying with this, do I have k pairs? I don't have k pairs because I just have one pair, 2 comma 2. Apart from this, I don't have any other pairs. So using this subarray, I don't have 2 pairs, right? So this is not a valid good subarray, and this is something we are not going to count. So you just need to count those subarrays which are valid, that is, which are good. Now, one of the method to solve this question is brute force. Okay, that is, you need to form subarrays, right? You can try with all the subarray and you can try with all the subarray and see if you can form 2 pairs or not, that is k pairs or not. I know this approach is going to give us time limit exceeded error because this brute force approach is going to create all the subarrays and check all the subarrays of how many pairs it can form. And if it can form k pairs, then we can say that it's a valid subarray. Now the time complexity is O of n square and space complexity is going to be O of n. But it is important to understand this algorithm, although it is going to give us the time limit exceeded error, and that's because it is going to set the path for us to understand how can we optimize this. Now what we do in this particular algorithm is, we have this as an input, that's our array, and we have k, right? You start from each of the index. You have total 7 elements here, starting from index 0 and going till index 6. Okay, 1, 2, 3, 4, 5, 6. Okay, and the elements are 3, 1, 4, 3, 2, 2, 4. We are going to start from each of the indexes, or we can say each of the elements, 3, 1, 4, 3, 2, 2, 4. And we are going to count how many subarray I can form if I start from 3. That is, I start creating the subarray like this. 3 is a subarray, 3, 1 is a subarray, 3, 1, 4, then 3, 1, 4, 3, then 3, 1, 4, 3, 2, then this and then this. Out of these subarrays, how many subarrays are going to have at least 2 pairs? I am going to calculate at each point. Then what I am going to do, Ignore this 3, start doing with 1. That is, start from the index 1. If you start from index 1, then this is a subarray, this is a subarray, this is a subarray, this. These are your subarrays. Then you will start from 4, and this is your subarray, then this. So like this you are going to create all the subarrays and count. That is, you will keep counting how many subarrays you can form, which is going to have at least 2 pairs. So when you start with 3, it is going to be 2. When you start with 1, it is going to be 1. When you start with 4, it is going to be 1. And when you start with this 3, or this 2, or this 2, or this 4, for all of it, we are going to get 0 subarrays, which is going to have at least 2 pairs. For 3, this is 1 subarray, okay? Because we have 1 and 1, and then we have 1 and 1. We have total 2 pairs. Then we have another subarray, right? And this is going to have 2 pairs, 1 and 2. So we have got 2 subarrays from 3 to 2 and 3 to 4. That is going to have at least k pairs. When we start from 1, we are going to have 1 such subarrays. This is our subarray. We go from 1 and go till 4. So we have got 1 and 2 pairs. Okay. So this is valid. We have another subarray which is starting from 4, and this is the subarray. 1 and 2. We have got 2 pairs. So it is also valid. So we have got 2 plus 1 plus 1, which is equal to 4. And in this case, the output is also 4, right? Now what is the procedure? What we are going to follow here is, when we are at this point, now what is the procedure to find out how many subarrays we can form? See, this is the algorithm, but what's the actual process? Let me try to show you with another example. Let's say this is your array, okay? In this array, you are trying to form all those subarrays which are having at least 2 pairs. The value of k is 2. In the example, the value of k is 10 for this array, but let us say the value of k is 2. Okay. Now we start from each index 0, 1, 2, 3, and 4. We have 5 indexes because we are having 5 elements. Now when we start with 0, what we are asking here is, my current element is 1, right? How many pairs I can form with this 1? At this point, I cannot form any pair, right? Because I don't have any more element in the left hand side. So this is my subarray, and I cannot form any pair, right? Now what if I increase the size of my subarray? Because I saw that this cannot form a pair. Can this form a pair? That is, if I give one more element, can you form a pair? That's the question. So if I am at index number 1, my current element is 1. Now I am going to create a map, okay? And this map is going to store the count of each values which we have already seen. So when we are at this point, we are asking the same question, that do we have an element which is equal to 1 so that I can form a pair? At this moment, this particular one is going to create a pair with the one we have already seen. Okay, the number of pairs are going to be equal to 1. So for this subarray, we have got 1 pair. Now the important thing to understand here is, every time you see an element, you are just going to ask the same question: have I already seen this element? If yes, I can form pair with each element which I have already seen. Okay, so for this one, I can form a pair, right? Now this is my subarray. I can form 1 pair. I need at least 2 pairs, right? So this is also not valid. This subarray cannot form 2 pairs. But we have got a good information after processing this subarray, and I will show you how. The moment you are trying to process this input or this particular data, which is at index number 2, now your subarray is something like this. The moment your subarray is something like this, what you are going to do is, you are going to ask the same question again, that if my current element is 1, how many 1 I have already seen? I have seen 1 plus 1. I have seen 2 ones, right? So I can take this particular one and form 2 pairs, pair 1 and pair number 2. So at each element, I'm just going to ask a question that, have I seen this element previously? If yes, with each element which I have already seen, I'm going to form a pair. Okay. So I already had a pair, 1 and 1, this one. Now using this element, I have got 2 more pairs, pair number 1 and pair number 2. So 2 more pairs, and without using this element 1, I already had a pair, right? So 2 plus 1 is 3. So at this point, when your subarray is this, that is, you are starting from here and now you are processing the elements till this point, you will have 3 pairs and you need at least 2, right? So right now you can say that this is a valid subarray and I am going to count it. So at this point, I have one subarray which has at least 2 pairs, okay, or at least k pairs. Now you can process the next element which is also 1. At this point, you are going to ask the same question: have I seen this one previously? Yes. How many times? 1, 2 and 3 times. So with this one, I can form 1, 2 and 3 more pairs. Without this one, I already had 3 pairs, right? With this one, I can form 3 more pairs. So I have 3 plus 3, 6 pairs. So now I can say that even this subarray is fine. This subarray is valid, or I can say it is a good subarray. So I have got total number of subarrays as 2 when we are starting at this particular index. What are those subarrays? 1 and 2. I can include this element as well, and I can say I have already seen this one 4 times. So I am going to form 4 pairs with this element. 1, 2, 3 and 4, right? I already had 6 pairs without this, and using these elements, I got 4 pairs using this. So it's 6 plus 4, that is, I got 10 pairs. I got 10 pairs, and now I can say this is also a valid good subarray. So I have got 3 subarrays when I am starting at this point. Now I am starting at this point, but I will do the same process. I will check with this element, then this, then these elements, and then these elements, right? This is something we are doing in brute force, okay? And that is why the complexity is O n square, the time complexity, and O n is the space complexity, because we are going to store the mapping of how many elements we have already seen. That is the counter of my elements. So we need to find an algorithm which can solve it in O of n instead of O n square. And that algorithm is called as sliding window. This is going to solve this particular problem in O of n and O of n. But before we see that, let me show you the solution for this brute force algorithm, because that is very important. We need to know the brute force so that we can optimize it, right? So let me show you the solution. What we are actually doing here is we are just having a count which is initially 0. N is the length of our numbers. That is the numbers array. Then I am just trying to run a loop. I am trying to set my current element as the first element of my subarray, and then I am creating a data dictionary. This data dictionary is going to store the count of each numbers which I have already seen. Okay, the number of pairs which I am going to form when I am starting with this particular number. Or let me go back to the drawing pad and show you that when I am starting at this point, how many pairs I can form when I am at this subarray, or at this subarray, or at this subarray. So this pair is going to store that value. Then I am running another loop from my current element to all the last elements. So I can say pairs is going to increase, and pairs is equal to pairs plus the number of times I have already seen my data. That is basically saying that if my I is at this index and my j is at this index, the number of pairs are going to increase if I have already seen this 4. Okay. For example, if I am at this point 3, the numbers of pairs are going to increase. This is j, this is I. So at this point, I can say that I have already seen this element 3. How many times? 1 time. So the number of pairs are going to increase by 1. Okay. And that's what we are doing here. We are just saying pairs is equal to pairs plus data of nums of j. This is my current element in my j index. Then I'm going to increase the counter as well. I will increase the counter after I increase the number of pairs, and that is because I don't want to create a pair with the current element. That is, if I am at this particular index, I don't want to count 3, 3 with the same 3's. Okay, I just need to count those pairs which I have already seen. So 3, 3 is a valid pair. But if you count this as well and then try to create the pairs, so what you will do is you will say 3, 3 and then this 3 and then this 3 again. So you can form 2 pairs which are invalid. So you need to increase the counter later on, and any time you see that the pairs are more than or equal to k, then you can say count is equal to count plus n minus j. Now this is very important to understand that why n minus j. Okay, see, we break after this and we just return the count value after processing all the data. Now just let me show you the important information that why the formula is n minus j and why I am breaking out of the loop. That's also very important to understand. See, if I say that this is a subarray which can form 2 pairs, right? That is, this is my subarray. If this is my subarray, then if I increase the number of elements in this without decreasing the number of elements in the left hand side, then I am sure that if I add one more element or add one more element, the number of pairs are going to be at least 2, right? If this is having 2 pairs, then if you increase the size, then all those arrays are going to have at least 2 pairs, right? And the question is about at least and not exactly. Okay, so what we are going to do is, the moment I see that at index 2 I got my subarray which is starting from the index number 0 going till index number 2, this subarray is valid, or we can say this subarray is a good subarray, then all the elements I can just keep adding 1 times and keep increasing the number of subarrays. I got my subarray at index number 2. I have total 5 elements. So I can say 5 minus 2 equal to 3. I will have 3 subarrays which are valid. 1, then 2, and then 3. And that is the formula. Okay. So if I just go back to the code, you can see that the moment I get that the number of pairs are more than equal to k, I can say count is equal to count plus the number of elements I have minus my current index. Because I can just say all the remaining indexes are going to form that subarray which will have at least k pairs. I can just count it and break it. And that's like avoiding to check for more subarrays, because I will know that if this can form a particular subarray which is having at least 2 pairs, then adding more elements are definitely going to add up more pairs. And we just need at least k pairs, right? Alright, so this is the brute force which is fine with O of n square time complexity. But let us see the algorithm which is actually going to solve this problem, which is called sliding window. This is going to solve this problem in O of n and O of n. Time complexity, space complexity. Okay. See, the logic is going to be pretty similar to what we have already seen, but this is going to be a more enhanced version of it. Let me show you how. This is your array, right? And the value of k is 2. What you are going to do is you are going to do the same thing. That is, you are going to start from each index and you are going to check what are the number of subarrays I can form. If I start at 3, or if I start at 1, if I start at 4, ... right? Now when I start at 3, I am just going to store the mapping. That is the count of each element I have seen. I am going to store that mapping till the point I get at least k pairs. Okay, that is 2 pairs in this case. Now when we are starting at index number 0 and the element is actually 3 here, so what we are doing here is, this is my left, okay, and this is my right. I'm just going to shift my right, and I will keep shifting my right till the point where I am able to create a subarray from my left to my right, such that I am having at least 2 pairs or at least k pairs. And I'm also going to update my mapping as well. Mapping is going to store the count of each element which I have already seen. Now this is my left and I go till here. This is my right. At this point, you can see that this is my left, this is my right, and this is my mapping. That is, in this particular array, I have seen this 3 2 times, 1 and 2. I have seen this 1 times, that is 1. I have seen this 4 1 times. I have seen this 2 times. Now at each point, I am going to actually count the pairs in the same way I was doing in brute force. If my left and right are at 3, then the mapping will be empty, right? At this point, I am going to ask the question that, hey, if my current element is 3, have I already seen an element which is equal to 3? No. So the number of pairs after processing this is going to be 0. But the mapping is going to have a value which is 3 is counted as 1 times. Now when I am at this point, again the number of pairs is 0. At this point, number of pairs is 0. I'm just shifting my right pointer. But the moment my right pointer reaches to this 3, my mapping will look like 3 is 1 time, 1 is 1 time, this one, and 4 is 1 time, right? And now I see an element which is equal to 3. I have already seen an element which is equal to 3. So I have one pair. I have an option to create one pair when my left is here and right is here, right? One pair at this point, and then you can increase the R, that is the right index, and create a subarray from this place to this place. This is your current mapping, and this is the index. This is index number 5. The number of pairs are 2 because now we can form another pair. The moment we get the number of pairs as 2, what we are going to do is we are having one subarray right now, which is valid. Okay. At this point, it is very important to understand that the count is going to increase. We have got 2 subarrays, and that is because if this is a subarray, then this is also going to be a subarray. The remaining elements are also going to count, right? So n is equal to 7. The current index is equal to 5. So n minus current index, that is going to be the number of subarray you can form, which is good subarray. So I can say count plus 2. 2 because 7 minus 5, n minus the current index, the index where r is. Okay. Now after processing this from L to R, we are having 2 subarrays, right? The next point is, if I have this as a subarray, can I actually remove this element left? Can I shift this element left and put it one place ahead? So let us do it. If you have L here now, a lot of things are going to change. But our goal is the same. Okay. This is our subarray. I need to find out if this is my subarray, can I have the number of pairs at least k? Let us see that. See, we just removed the element 3 from our subarray, right? So our mapping is going to be updated. So we had this element 3 2 times. After updating, we will have it 1 time, right? So my count of 3, which was 2 earlier, is going to decrease, right? 3 is 1 times now. Now the question is, if you have removed this element 3, earlier your window was this, right? This was your subarray. You removed this element and now this is your subarray. You updated your mapping, right? Which is fine. But is the pairs also getting updated? That's the real question. Yes, we had 2 pairs with this subarray, but the moment I am removing an element which was contributing to the number of pairs I was forming, then the pairs will get affected. And how can we find it? See, I removed an element which is 3, but I'm still left with an element which is 3, right? The count of 3 is 1. It means I removed an element 3 which was actually forming one pair. Okay. So the moment I remove an element, I'm actually removing the number of pairs as well, right? So I have 2 pairs. Now I have just 1 pair, right? Because I removed this 3. And if the number of pairs are not at least k, then this is not a valid subarray. In this case, I'm not going to change the left counter, but what I'm going to change is I'm going to change the right counter. What I'm going to say is, this is my subarray now. My R will be this. Okay. This I'm going to do when the number of pairs are not at least k, right? Now the moment you do this, you are actually updating your mapping again, right? Now your mapping will have 4 2 times. It had 1 times. Now it will have 2 times. At this point of time, you are also going to update your pairs. You had 1 pair, right? Now after you added this element 4, you will have 1 more pair because you already have an element 4. You have a 4, you are adding a 4, so you can form a pair with this, right? So now you will have 2 pairs again. And the moment you get 2 pairs, you will say, okay, I got another subarray. How many subarray will I create? It depends upon how many elements are there after 4, right? After 4, there are no elements. So at max, I can create just 1 pair, and the formula is n minus index. Now my current index where my R is, it's at 6, right? This is my index number 6. So I can say index 6 and n is equal to 7. So 7 minus 6 is equal to 1. So I will have 1 more subarray. I already had 2 here, right? So 2 plus 1 is going to be equal to 3, right? So this is 3 now. Now the next thing is, I will do the same thing. I can just say, the moment I get a subarray which is valid, I can just update my L. And what I can say is, L will be here. That is, I'm shifting, I'm sliding my windows. Okay, now this is a subarray. Is this valid or not? The moment you will see this, you will say, hey, I removed an element which is equal to 1, right? You removed this 1 now. And at this point of time, your mapping is going to be updated. You had 1 once, but now you have 0 number of ones. But are you actually forming any pair with this 1? You had a 1, you removed it, now you don't have a 1. If you don't have a 1, this 1 was not actually pairing with anyone, right? Because you have 0 ones left. So if this was not pairing with anyone, this was not contributing in the value of pairs, then the value of pairs is going to be same, 2 and 2. Now we still have at least 2 pairs, right? So we are going to increase the count again. The right pointer is not shifted, right? In this case, I can say n minus index again. And what is my index? Index is equal to 6, n is equal to 7, 7 minus 6 equal to 1. So I have got one more data. I already had 3, right? I had 3 subarrays, I got one more, so I have got 4 subarrays. Now after this you are going to do the same thing. See, what you can do is you can shift this L, okay? You can say this is my new L now. Now the moment you see that this is your subarray, I have removed an element 4 which was actually contributing to a pair. The number of pairs are going to decrease. We have 2 pairs, it is going to be 1 now. But we don't have more elements to add up, right? So at this point of time we can just stop and say that we have finally got 4 subarrays which are valid. And that's the algorithm of sliding window, okay? It's very much similar to how brute force work, but we are not running 2 loops. Here what we are trying to do is we are just having L and R at the same pointer, and I'm just shifting the value of R till the point I'm getting an answer. And when I'm getting an answer at any point, I'm just shifting my L pointer then, okay? And if shifting my L pointers get me to an answer, I'm again shifting my L pointer. But if shifting my L pointer is not giving me the correct subarray, I'm shifting my right. So add an element if you need and remove an element if you can. That's the algorithm for sliding window. And let me actually show you how the code looks like. So the code for sliding window looks something like this, and if you try to compare it with brute force, it will look very much similar, but the trick is a bit different. You have a counter, you have the n as well, and now you have a data dictionary which is outside of your loop. See, here we were creating a data dictionary every time we were starting with a new element, but here we will have a common data dictionary which will get updated when we see a new element. The number of pairs which we have and left index is going to be 0. Now we are going for right index which will go from 0 to n, and my current element is nums of right. My pairs, how many pairs I can form? I can form pairs is equal to pairs plus data of current, and that is basically saying that pairs is equal to pairs plus data of nums of j in the brute force. And here in the sliding window algorithm, the process is same. Pairs is equal to pairs plus data of current, that is how many pairs I can form with my current element, and then I'm going to update my current element, that is the count of my current element. Now till the point I'm getting a pair which is more than equal to k, that is I'm having at least k number of pairs, then I'm just updating my counter. Count is equal to count plus n minus right, and then I'm going to shift my left pointer again. And before I shift my left pointer, I'm going to update my mapping, that is I'm going to decrease the count by 1, and the number of pairs are also going to decrease if that particular number which got removed is actually contributing to the number of pairs which we have right now. So this is the complete algorithm for sliding window, and this actually works, right? So if you submit this particular code, you can see that its runtime is good, its memory is good, so it's almost the perfect algorithm for this particular question, or I would say not almost, but it's exactly the algorithm you need. So that's it for this video, guys. I hope this video explains you the question as well as the approach to solve this question, and if it did, then make sure that you hit that like button, and if you are new to the channel, then make sure that you subscribe to my channel as well, and I will see you guys in the next video. Thank you for watching this video, guys.